Hi guys, welcome to this video. This is one of the videos in the series where I talk or teach trigonometric graphs. This is for grade 11 and 12, but grade 10 people can also benefit because they're videos that have information that's useful to them. This will be a playlist or series. We'll have videos on explanations first, then later we'll look at past question papers. So if you're done with the content, you can go straight to the question paper videos. They're written question paper on them. The way to watch these videos is best when you can best watch these videos by trying the problems while you see them on the video, pausing the video and trying the problems, and then checking if the video will explain the same answer that you got when you tried the problem. So if I say I'm gonna draw a graph, you try drawing the graph first, and then see if it's the same as the one in the video. If there's a problem I'm trying to solve, you try to solve the problem first, see if it's the same. So please watch the video, and nice thank you for watching. Hi guys, in this video we'll be looking at the amplitude as well as the vertical shift in the trigonometric functions. Now, first thing we're going to look at is if you have a mother graph, say for example this sine graph, and you put a value or a constant in front of the ratio, that will change the amplitude. Because think about it, let's say I put 90 degrees here in this graph. If I put 90 degrees here, I will get 1. I'll get 1. You can put in a calculator to confirm. Now, if I have 2 in front of sine x, and I put 90 degrees here, this will give me 1, but the 1 will be multiplied by 2, which means the final answer will be 2. And therefore, the graph will end at 2 if it has a 2 in front of sine x. Yeah, I hope that's understood. Then if you have a negative 1 in front of sine x, not a 2 now, a negative 1, what's going to happen is, let's say you put 90 degrees again, but you have a negative 1 here. You are going to get 1 for sine x, but then it's going to be multiplied with a negative, and you get a negative 1. That means your 90 will be equal to negative 1, so your graph will go down like that. So it will go like this. That's something important you need to know on the amplitude. Now let's get into sketching graphs with the amplitude. Let's sketch the graph of, okay, what we are exploring here is y is equal to a sine x as well as y is equal to a cos x. First graph we're gonna draw is the graph of y is equal to 2 sine x. Let's draw that graph. You have your x's, and then the graph, the only thing you put is the amplitude. It's 2 now, so it's going to look exactly like the mother graph. The only difference is it's going to be stretched vertically. It's going to be stretched. Now your graph is going to look something like this. It's going to be a bit taller than the mother graph, but the points are still the same, the intersection with the x-axis. So here it'll still be 360, here it'll still be 180, exactly like the mother graph. Here it'll still be 90, here it'll still be 270, exactly like the mother graph. This is the maximum, this is the minimum, this is the maximum, but the only difference is the maximum for the mother graph was 1, and now it's multiplied by 2. Therefore, this graph is going to end at 2. The minimum for the mother graph was minus 1, but now it's multiplied by 2. So minus 1 multiplied by 2 is going to give us negative 2. And that's going to be your new graph. That's how it's going to be. This is how it's going to look, this one. Now let's move on to sketching y is equal to negative sine x. Y is equal to negative, okay, this is y, this is x. Y is equal to negative sine x. For y is equal to negative sine x, it's going to look the same as the mother graph, except it's going to be reflected about the x-axis. So it's going to be upside down. It's going to be upside down. The mother graph goes up like this, so this graph is going to go down like that. So let me draw the mother graph in a dotted line, and then I'll draw this one. The mother graph would look something like this. So this graph is going to look like this. Okay, now this point is still 360, this point is still 180, this one is 270, this one is 90. This is x, this is y. This is now your new maximum. For the mother graph, it will be your minimum, since the mother graph is this dotted line. But for this one, it's going to be your maximum here. But your maximum is still going to be 1. It's not going to change. And your minimum is now here at 90 degrees. And it's going to be negative 1. That's your y is equal to negative sine x. This is your y is equal to negative sine x. Let's move on into sketching the graph of y is equal to negative 3 sine x. For the graph of negative 3 sine x, draw the axis as normal, y, x, and then notice we didn't do anything to how the graph is shaped this way. We didn't squeeze it, we didn't extend it. It's always the same if you're only changing the amplitude. The only thing we did is changing the height. And also, we didn't move it upwards, we didn't move it downwards, we didn't do anything else. We just changed the height of the graph. Just the height. That's the amplitude. Now, let's look at this one. This one is y is equal to negative x. We are still only changing what is the coefficient of sine x. So we are still only going to change the height. Now, the height for here, first thing you need to notice is it's negative here. If it's negative, it's going to go down first. If it was positive, it was going to go up first. But it still forms an S. So since it's negative, it's going to go down like this. And it's negative 3, which means that it goes really high and really low. Now let's try drawing this. It's going to go something like this. And this is still going to be 360, still going to be 180, still going to be 90, still going to be 270 degrees. The maximum, you look at 3, it's going to be 3. It's just going to be 3. Keep it simple. It's going to be positive 3, and your minimum is going to be negative 3, because the amplitude is 3. It goes up 3 units, it goes down 3 units. That's finally that's our last sine graph. Now let's go to cosine. For cosine, we are first going to look at y is equal to 3 cosine theta. It's the same thing for cosine and sine. So in this case, I'll first show the cosine, the normal mother graph for cosine, just to show the difference between the two. So the mother graph for the cosine looks something like this. This is 360. This is 180. This is 90. This is 270 degrees. Okay, now this is 3 cosine theta, so we have to make this theta, and then we have to make this y. For wait, for 3 cosine theta, it's still going to go up first, but it's going to go 3 units up. It was 1 for the normal cosine and -1 at the bottom. Now it's going to go 3 units up. So we have to estimate about 3 times this. So it should start somewhere around here. But I'm not going to draw it to scale just because I can't draw here since my arrow ended here. I'm just going to start here. My graph's going to start here and go like this. Right? And then it's going to go down like so. And then it's going to go up like that. That's our new y is equal to, this is this graph. It goes higher, it goes to the same point here, it goes lower, goes to the same point here, goes higher again, right? The period is still 360. Period here is still 360. I've never changed the period in any of the graphs that we've done in this video. It's still 360, but the amplitude now is 3, because the amplitude is the number that's the coefficient of the ratio, or rather the absolute value of the number that's the coefficient, which is basically the positive version of this. If this was negative, the amplitude will still be 3. Alright, let's go to another graph. Okay, sorry, this is 3, this is -3. The next one we'll do is y is equal to minus cos theta. For y is equal to minus cos theta, I'll first draw cos theta. Cos theta looks something like this. That's the mother graph, ne? Mother graph. 360, 180, 270, 90. I would advise that if you're drawing graphs, if you're drawing sine, and it's only the amplitude that was changed, it's better to use 90, 180, 270, and 360 than to use 60, 30, and all the other numbers that are confusing. So it's better to use this scale. If you want, you can add 45, 135, and so on. It's better to use this scale rather than to use the scale that is 0, 30, 60, 120, 150. Yeah, but that one is confusing because you won't know where the maximum, you won't know where the intersection with the x-axis is. Yeah, but there's no, wait, no, there's 90 here. Okay, actually you can use this. You can, because you have 90, you'll have 180 here, you'll get 270, you get 360. Okay, you can use this, but I just prefer this one. It's easier for me. Now let's go into sketching. Oh, sorry, we didn't sketch this one. This is negative cos theta. For negative cos theta, it went up first and then went down. For negative cos theta, it's going to start at the bottom. It's going to start here at -1. It's going to start here and it's going to go up and it's going to do that. That's negative cos theta. It's reflected. Whatever was happening here is now happening here. Whatever was happening here is now happening here. It's been reflected about the theta axis, if that's a thing, because this is theta, it's not x, so it's not, I don't think it's the x-axis. Now let's sketch the graph of y is equal to -2 cos theta. For this graph, let's try being faster now. For this graph, it's going to start at the bottom but the amplitude is 2, so it's going to end at -2. It's going to end at 2 there. So it's going to be something like this, right? It's going to be shaped like this one, but it's going to start at -2 and going to end at 2. Same time, same period, 360, 180, and the others. Right, now that was our basic sine and cosine graphs. Now watch the next video for the change in the vertical shift. We've reached the end of the video. Thank you for watching. Please subscribe, tell your friends to come and watch. Leave recommendations on what I should do on the next video. Anything you need me to explain, any topic, any questions. Now I just want to talk to you guys about a few resources you can use. Firstly, we have the Desmos Calculator. It's a website online where you can write a formula for a function, and then the website will graph the function for you. You can use that to confirm your answers. So you can make up a trig graph, maybe an equation, try graphing it, and then go enter your graph into Desmos Calculator to compare it to yours, so you can see if you're correct. So there you can graph basically any graph you want. I'll leave the link to the Desmos Calculator in the description of the video. You also have the Science Smart Study Guide. I like this study guide. I like using it when I was doing matric. It has really compressed information. It has everything you need, but it doesn't have anything you don't need. So it only talks about something that will help you in your exam. It doesn't go around the corners and talk about useless stuff. I would recommend that. I'll leave the link in the description. If you want to use that, you have to go enter your name and your email, but it's not paid for. You just enter your details and they'll email you a link, and you go to your emails, press on the link, and then the file will download on your phone. It's a study guide. It's a really short, amazing study guide. And then you have chapter 1, Trigonometry. This is a document. I don't know where I got it, but I'll make it available on my Google Drive. I'll leave the link in the description as well. You can go to that link and go download chapter 1, Trigonometry. This one is for the math enthusiast. If you like maths, you can go use this. It's very detailed. It's amazing. I used this when I was in matric, and it has deep explanations. Well, not deep explanations, but it's detailed enough to let you know what happened. Then you also have past question papers. You can get past question papers from Stanmore Physics. You can get them from essay exam papers. You can get them from Department of Basic Education, and there are many more websites you can get past papers. You can use a lot of resources to study aside from this. The important thing is you just have to practice and practice and practice. Once again, thank you for watching. Please subscribe, like the video, share with your friend, turn on notifications. Whatever button you see at the bottom, just press it. Thank you.